Friends, in this video we're going to talk about this question which seems difficult, but I'll tell you how to solve this question with a very simple formula. The question is, three particles A, B and C are situated at the vertices of an equilateral triangle ABC of side D. At time t equal to 0, each of the particle moves with a constant speed v. A always has its velocity along AB, B along BC and C along CA. At what time will the particles meet each other? That we need to find out. See, in this question this is mentioned that A always has its velocity along AB, B along BC and C along CA. What does that mean? That means A is always moving towards B, B is moving towards C and C is moving towards A, right? And eventually they are moving on this curved path and they are meeting at O. And then we need to find out that what is the time taken by the particles to meet. The very simple concept that I'm going to use is time. That we all know, time is distance by speed. But in terms of displacement, we can write this as time is displacement by velocity. But the condition is that direction of displacement and velocity has to be same. Only then you can use it. So I'm going to use time is displacement by velocity to solve this question. This is the formula that we all know, right? So that's what I'm going to use here to solve this question. So first of all, let us find out the displacement. For the particle B, the displacement is going to be BO, and same for other particles also, right? So this distance BO, let us consider that as x, right? And if you draw a perpendicular, let's take this point as M, right? So if you talk about the triangle BMO, this length BM is going to be d by 2, because entire length of the triangle, entire side of the triangle is d. So this is d by 2, right? And this angle is going to be 30 degree. So what can I say from the triangle? I can say that the x cosine of 30 degree is going to be d by 2. So from there we can get the displacement x. So what is x? That is d by 2 by cos 30. So cos 30 is root 3 over 2. 2 get cancelled out, and the displacement that we got is d over root 3, right? Now what we need to find out? We need to find out the velocity which is along displacement. So the velocity is going to be this one, which is v, but we need the component of v along BO, along x, right? So what is that? That is v cos theta. This is going to be the component, that is v cos of 30 degree, right? So if I'm going to use this to get the time, so the time is going to be d by root 3 by velocity. So what is the velocity that we got? Velocity we got is v cos of 30 degree, right? So that I have to use here now. So it is v into cosine of 30 degree, which is what? Root 3 by 2. So the time is going to be, this 2 will shift up, so 2d by root 3 into root 3 becomes 3, that times v. So time that we got is 2d by 3v. See, we got the answer easily with the help of a formula. Time is displacement by velocity, but their directions are same. That's the thing we have to keep in mind, right? So time is not only distance by speed, this is displacement by velocity also, but in that case the direction of displacement and velocity has to be same. So we can use that to solve a difficult question. Thank you.